Welcome to the next chapter. We're still on acid-base equilibria, and here's some common household acids and bases. And this is part 4. Several parts to this chapter, and I'm Ms. Bedrosian. I want to clear up a little bit of confusion on the equivalence point. The equivalence point is also known as the stoichiometric point. You cannot see this. This is when the exact number of hydrogen ions equals hydroxide ions. You cannot see this. What we can see, however, is the end point. The end point is when the indicator actually changes. That's when you can see it. So the equivalence point we cannot see. We see the extra when the hydroxide or whatever it is combines with the indicator to change color. And you can see here on the graph, that's the point that we see. We consider it negligible difference in volume. So we see the color change at the titration endpoint. All right, we're going to do an example, practice problem. A mixture of CCl4 carbon tetrachloride and benzoic acid weighs 0.3518 grams. You have a solid mixture of these two things, and you are going to add some water. After mixing it with water, it was titrated with 10.59 milliliters of 0.1546 molar sodium hydroxide till it reached neutralization. That's how much was required for neutralization. So the question here is you're going to have to figure out the mass percent of benzoic acid in the original sample. And how will you do that? If you know, pause and work it out now. Otherwise, you might want to give it a think about what's going on here. Here you are. You're thinking. Let me think about this. Oh, I think I got some of this now. You say to yourself. Carbon tetrachloride. That it does not react with a base. It's not an acid, so it won't react with the hydroxide. We can eliminate that from our thinking at this point. Yeah, pretty good. What else? What else can I think of? Oh, I know. The hydroxide is so strong that it will yank that hydrogen ion off that weak acid. So the reaction will go to completion. Yeah. You must be a genius, That's what you're thinking now. Yep. Oh, there you are. You're a genius. Right here. Right here. Genius. All right. So let's go right to it. And you know it always starts with that balanced equation. This is what's actually happening. So that H and OH form water, and then you're left with the benzoate ion. So part 1. Solve for the number of moles of hydroxide. If you want to solve, press pause. Otherwise, here's the answer. Why do you need to know that? Well, you know that information. I gave you milliliters, I gave you molarity. So you know moles. And there's the answer. That's the number of moles of hydroxide. If you know the moles of hydroxide, what else do you know? Well, looks like it's a 1-to-1 relationship here. This must be equal to the number of moles of benzoic acid. Ooh. So what's your next thought? Well, if you know the moles of that, Oh, you're so happy about it. Then you know the moles of that. So change the moles to grams of benzoic acid. That'll give you grams. Do that. And here's this answer for the grams. Well, if you know the grams of that at the start, I did give you starting amount of the mixture. So solving for mass percent will come next. You should be able to do that. I will show you the answer. Solve for mass percent. And of course, that's always part over the whole times 100. And the starting amount was 0.3518 grams times 100. And you will get 56.82%. Hope you got that. And I'm going to cut this short. This is end of part 4. Welcome to the next chapter.